Serial communication refers to sending data between devices one bit at a time. So this is in contrast to parallel communication, in which multiple bits can be sent in parallel over a bus. So an advantage of serial is that less wires are needed. Obviously there is a disadvantage that you're only sending one bit at a time, so it'll take longer to send the same number of bits as it does over parallel communication link. So there are two main types of serial communication. We've got asynchronous and synchronous links. So with asynchronous serial, there's no clock signal. This means that the devices must ensure they're using the same baud rate. Now, the baud rate gives us the speed of the link in bits per second. So 9600 bits per second is a very common baud rate you'll come across. And typically the maximum supported by microcontrollers is 115200 bits per second. So you can see this is nowhere near megabits per second. It's often perfectly adequate for what we need in typical applications. And then all microcontrollers tend to have a universal asynchronous receiver transmitter peripheral. So this is a common UART or just a common serial port. It's probably the most common communication protocol you use in embedded systems. So a UART has two pins. So it's got a transmitter pin, so I often use TX to denote that, and a receiver. So this is obviously where RT comes from. So it's a receiver and a transmitter. So when you connect up devices, as we can see, it's very important that you put a crossover. So the TX of one device, that's transmitting data, so that has to go into the receiver on the other side, and the same with the receiver on, so if we call this device A and device B, the receiver of device A connects up to the transmitter of device B. Because normally when you're following a circuit schematic, pins with the same name are normally connected together. But not in the case of a UART. You need to remember to put this crossover in. So when we're transmitting a 1, so the period where we're transmitting a 1, the transmit line, well, in the case of this LPC 1768, the transmit line is at high 3.3 volts. And when we transmit a 0, the TX line will be low. So because you're sending a voltage between these two devices, there must also be a common ground signal as well. So these devices can be wrought. So this of its own ground, obviously device B of its ground. So it'll often be 3 wires between the devices. You'll have the transmit and receive connections plus the ground connection. So obviously then the voltages will be referenced to the same ground value. So another definition you need to be aware of is duplex. So a duplex communication link is one in which communication can happen in both directions. So UART is an example of this. We saw on the previous slide we've got device A and B. They can, A can send to B and B can send to A. So this is duplex. And then a full duplex link is one in which this two-way communication can happen simultaneously. So at the same time A is sending to B, B can be sending to A. So UART is also full duplex. It's got a separate transmit and receive line. Some communication protocols share a transmission line, so they need to transmit and receive, need to take it in turns. But when you've got a separate transmit and receive line, they both can happen concurrently, and that's what we call full duplex. So we'll look at this LPC 1768 block diagram. We'll see we've got several communication links here. We've got the UART peripheral. And then we've also got these other ones we'll look at later. So I2C or I2C, integrated circuit communication, and SPI, so serial peripheral interface. So these are the types of serial link. So we'll look on this embed kind of block pinout now. We'll see there's several serial ports. So we've got 3 different serial ports connected up, so you can see each serial port has got a transmit and receive pin, and then also there's a fourth one actually on the USB. So we'll use this. This is very commonly used. So this these two lines are called USB TX and USB RX, and this is so when you've got a USB connected between the microcontroller board and the PC, you're able to communicate between the microcontroller and the PC. So we can see this memory map. So we've got the 4 different UART peripherals here. I think UART 0 is the USB one, and then we've got 1, 2, and 3, and also we've got we've got the SPI and I2C. So there's multiple I2C peripherals as well.